NASA historically restricted the routine personal use of consumer smartphones in space, but a major policy shift is finally bringing our most essential daily tool to the final frontier. NASA Administrator Jared Isaacman announced in early February 2026 that astronauts on the SpaceX Crew 12 and the upcoming Artemis 2 lunar flyby missions are officially permitted to carry personal smartphones, including iPhones and Androids. This small step reflects a cultural change, moving away from historically conservative electronics policies towards embracing modern, intuitive consumer hardware to help crews capture and share special moments with their families and the world. While this is the first time smartphones are allowed for routine personal use, they have been in orbit before as experimental brains for satellites. Back in February 2013, the UK's Strand 1 became the first smartphone-powered satellite, carrying a Google Nexus 1 to test if commercial electronics could control a spacecraft. Shortly after, in April 2013, NASA launched its own phone sats, including a trio named Alexander, Graham, and Bell, collectively named after the telephone inventor. These utilized off-the-shelf Samsung Nexus S and Nexus 1 phones to handle onboard computing and orientation. These early missions proved that consumer sensors like gyroscopes and GPS could successfully manage satellite avionics at a fraction of the cost of bespoke hardware. Inside the International Space Station, smartphones have been working hard for years as part of robotic experiments. Since 2011, Nexus S phones have been attached to bowling ball-sized Spheres robots, turning them into smart spheres that can take pictures, conduct inspections, and navigate using 3D maps generated by Google's Project Tango prototypes. Meanwhile, astronauts have long used iPads for ISS operations and public tours. But without gravity, these tablets don't know which way is up. To fix this, crews use a clever manual workaround. They toggle the rotation lock via the mute switch and physically jerk the iPad to simulate the force of gravity, tricking the accelerometers into rotating the screen. So, why did it take so long for personal phones to be authorized for everyday use? Historically, NASA was incredibly cautious because space is a brutal environment. The agency worried that intense radiation could damage modern chips, that electromagnetic interference might disrupt critical spacecraft systems, and that lithium-ion batteries pose serious thermal and fire risks. Until now, astronauts documenting their journey were largely limited to agency-approved professional gear, such as Nikon DSLRs and standardized action cameras. However, modern testing has shown that today's commercial off-the-shelf electronics provide capabilities that can meet or exceed mission needs once properly qualified, prompting NASA to expedite their approval for spaceflight. This shift isn't just about space TikToks, it's about affordable innovation and normalizing the human experience in orbit. By qualifying off-the-shelf hardware, NASA is lowering the barriers to entry for startups and proving that space exploration is a shared human endeavor. As the Artemis program moves closer to the moon, future lunar landscapes may soon be captured through the same smartphone lenses we use every day, bridging the gap between our analog past and a digital future. In this video, you learned about the evolution of consumer electronics in orbit and how NASA moved from experimental phone sats to officially authorizing personal smartphones for deep space missions. If you want more fascinating lessons like this, make sure to follow.